this is really cool that everyone's here. Svelte has always been a very community-centric project. Even though I'm kind of like the public face of the project, everything that goes into it, like all of the design decisions, the way that the templates are structured, all of that stuff has been hammered out by a community of people who are sometimes quite boisterous in expressing their opinions, and like if you show it with a bad idea, then it quickly gets thrown out. But it's fun and it's collegiate and it's collaborative, and it's why the framework is the way that it is today. The thing was that even though it was very community-centric, until recently it was a very small community. And this year it became not so small when we launched Svelte 3. We now have more than 200 people who have contributed to the Svelte repo in some form or another, which is really cool. People from all around the world, every continent apart from Antarctica, I believe. And it's true that a lot of these contributors are people who are just adding their company to the list of people who are using Svelte. But that itself is a great thing. It's a sign that people are actually using this to do real stuff, which is very exciting to me. This was the London meetup, the first ever Svelte meetup, which happened in a pub in Islington, I think, somewhere. I believe Anthony is talking about minimalist web design or something, because he's just pointing at a white square. And these are some of the other meetups that are either in the planning stages or are going to happen. So I think we can say at this point that Svelte Society is a thing, and for that I'm extremely grateful to Sean for taking the initiative. I think he deserves a round of applause for making this happen. And I'm also very grateful to all of you who've taken time out of your evening to go and be here. Quick opportunity to plug what we're using Svelte for at the New York Times at the moment, which is where I work, just over the road. So this weekend we published a story that Michael and I, Michael sat at the back there, have been working on for some time. And when I say Michael and I mean Michael. I sort of came in at the end and helped with some of the graphics, but we did a story, and just as a heads up, like it's pretty uncomfortable topic-wise, but I'm gonna give you a look at what it is. So this is a story about the proliferation of what is referred to as child sexual abuse material online, which has become a massive problem, particularly over the last few years. My task was to take the design work from two designers that we work with, Ramsey Taylor, Adriana Ramich, who had this idea about taking the subject of this article and putting it front and center. Like when you come to this article, we're going to confront you with the reality of what we're going to be talking about, and we're going to take what could be an abstract concept and make it concrete, which is, I think, one of the really powerful things about visual journalism, particularly visual journalism on the web using web technologies. So each of the images here, these were provided by the Canadian Centre for Child Protection. These are actual images that have been found by the centre, obscured using a neural network called the Pyramid Scene Parsing Network, or PSPNet, so that the people in these photos aren't re-victimized by people viewing them, and also the people who have to work with this material are protected from the effects of that as well. And as you get into the story, you start to see that this is a problem that is just exploding in volume. And recently we've reached a breaking point. And then we get to the headline and you start reading the story. So when someone comes to you and says, this is what we want, this is the experience that we want readers to have when you first open the screen, it's difficult on a news site because you have a lot of stuff. You have like analytics, and you have ads, and you have comment widgets, and all that stuff. So it's kind of difficult to just pile in lots of JavaScript and kind of solve it that way. And so this is where Svelte comes from. This is why I started the project, is because I'm a great believer in the power of web technologies to enable richer and more interactive and dynamic forms of storytelling, but we don't have a big JavaScript budget on news sites. We have to get things up and running very quickly. This is actually using, no, too soon. Using a project called Svelte GL, which is a very experimental, not ready for production WebGL component library, which you can use inside Svelte applications the same way that you might traditionally use something like 3JS or Regal, but it fits inside that very constrictive JavaScript budget. And you can actually play with it in the REPL that Sean was talking about earlier. This is a very simple Svelte GL scene with a little cube down there, which is defined by this mesh. Let me make that bigger so everyone can see what I'm talking about. This is a gl.mesh component, which is like all of the objects in your WebGL scene are created with a mesh component, and you provide it with some geometry. And there's a bunch of like pre-made geometry builders, like this GL box one. The one above is GL plane. And you pass in some parameters, and you pass in some WebGL uniforms, and hey presto, you've got a scene. And because it uses Svelte's reactivity system, you can use all of the same binding logic and everything that you normally would. So we can change the color of this, and we can use HTML form elements to control what's going on here, and we can spin around with that. So that is how the introduction to that article was built using this, and this is something that I hope that we'll be able to get to a stage where we can actually honestly recommend it to people to go out and build stuff with. Where was I going with all this? Ah yes, abstract syntax trees. So this is what I'm going to talk about this evening. Abstract syntax trees is a term that I first heard, I think it was 2011, and I was in the basement of a pub in London called the Shooting Star, and I got into conversation with a bloke named Alistair Dant, and we were talking about some kind of programming topic, some programming problem that I've been trying to solve, and Alistair was like, oh right, so yeah, you've been dealing with abstract syntax trees, and so here's the thing, right? Alistair had set up the Guardian's interactive journalism team in London, and they've been doing this mind-blowing work, and like he's kind of one of my heroes, right? And I don't want to like stand there and look like a complete idiot, so instead of being like, I have no idea what you're talking about, I was like, oh yeah, abstract syntax trees, yeah, definitely use those things, very familiar with them. And then so this is what UK meetups look like. They are booze fests. This is the transatlantic cultural divide, I guess. And I went home and Googled it and discovered that actually they're not that scary. And so tonight I'm going to be introducing you to abstract syntax trees, how they work in Svelte, and some of the work that is going on in the project at the moment to overhaul the code generation side of things. Also, as good fortune would have it, Alistair, who currently lives in the Bay Area, is visiting us in New York, so hi. And thank you for not calling my bluff all those years ago.
I would just like to say I'm very proud of Rich. So I would also say that I hired him as a result of meeting him in a pub. Well, after this pub, there was a following pub thing where he revealed that he was, where were you working at? What was that place?
Citywire.
So he's working with something called Citywire, but despite the fact that he was employed, what was your actual job at Citywire? It was kind of like make some.
I had a few different ones.
Yeah.
I was a web producer, which is a job title that they give to people who they don't know like what to tell them to do.
But he built a chart component library for no good reason other than the fact he thought he would do it, and he's continued on in that vein to the point we find him now, where he's taken over the world of JavaScript.
Thank you. So yes, ASTs. They are one of those things that sounds very confusing, but they're actually pretty straightforward once you've kind of got your head around the basics. This is a website that I absolutely love. It is the first website that pops up when I type A into my URL bar, because I use it all the time. And what it does is it tells you what the semantic structure of a JavaScript program is. It takes the input on the left and it turns it into the thing on the right. And I can turn this into a JSON view so you can just see the actual output. Answer equals 42 is an assignment expression with the operator being the equal sign. On the left we have an identifier whose name is answer, and on the right we have a literal whose value is 42. And it's kind of interesting to open a page like this and just kind of play around, put different code in, and kind of get a feel for what the computer sees when it's interpreting your code. For example, if I put let in front of this, to us it looks almost the same, but now it's a completely different structure. We now have this array of variable declarators with IDs and inits and all of this other stuff. And it's just kind of fun to visualize code in that way. AST Explorer actually lets you do...
That's a question.
Oh, yes.
Hey, isn't an assignment technically a statement, not an expression?
It is. It is an expression statement. So you have the program is a thing with a body which is an array of statements, statements or declarations, and an expression statement is a thing with an expression, and the assignment expression is the thing that I described. So yes, you're right. The difference between an expression and a statement is it makes sense to have a semicolon after a statement. It doesn't make sense to have a semicolon after an expression. That's kind of the easy way to remember the difference. So in AST Explorer, you can explore all kinds of ASTs, and I recently discovered that there is, in fact, I'm just going to grab some code from here. There is a Svelte parser inside AST Explorer. So you can see the AST that is being generated by Svelte when you type code in. But that's not what we're going to look at right now.
Quick question.
Yes?
Do you know if they did that by using Svelte code, or did they implement it themselves?
I have to assume that they're using Svelte's own compiler. It exports a parse function which generates that AST, and so you know, anyone can do that, and that's useful for if you're building like an editor extension or some syntax highlighting, stuff like that. So I think they're just piggybacking on that, but I haven't looked at the code. I'm not actually certain how that happens. Okay, let's move over to VS Code, and we can make this a little bit more concrete. So imagine that we had a program that just alerted the lyrics to the theme from the Italian Job. Everyone knows this, right? This is a self-preservation society. No? No one's seen the Italian Job? Come on. Okay, well, I'm importing a module called Acorn, which is one of several libraries which will take JavaScript code in and give you an abstract syntax tree out. And it's really good. I recommend Acorn if you want to dabble with this stuff. It's very cool. And if we run this code here, it'll give us a view of that program as the computer sees it, in the form of an abstract syntax tree. And maybe if we do JSON stringify like that, then it'll be a little bit easier to see. Okay, so that's what we get when we pass that code. Now let's imagine that we wanted to change this code. We want to change all of the alerts into console.logs. So the first thing that we want to do is kind of walk over the code and find the individual nodes inside. So we're going to import a little helper library called ESTreeWalker. ESTree is the name of the AST specification. Wait, didn't mean to delete that. I'm not as good at live coding as Sean is. I don't know if anyone's seen his talk from JSConf Singapore last year. He literally live coded a React clone in under 30 minutes, and it was pretty badass. So here, I'm just going to log out the types of the node like this. Okay. So if the node type is an identifier, and the node.name is alert, then we need then we know that we need to do something. But what do, right? And this is, I'm missing the and. Right, how are we going to actually edit this code? Now, the traditional approach that people have used for years is you take that tree and you return another tree and then you stringify that. And a few years ago, I was working on some stuff kind of adjacent to this, and I thought, well, that seems like overkill, honestly, because a lot of the time you just want to make like small targeted edits. And so there's this, a library that I wrote called Magic String, which is designed to do exactly this stuff. If we now say const code equals a magic string and we have the code and the AST side by side, then we can do edits. We can do code overwrite, and we'll take the start position and the end position. And then we'll just replace any instances of the alert identifier with console.log. So we're actually changing the structure of the program, right? Because that was an identifier, and now it's a thing called a member expression, which is different. And we can log out the result of doing that. Okay, so that's progress. And what's interesting about that approach is that you're passing in the original indices into that string, but magic string is keeping track of where that is in the current string, because every time you make one of these edits, you're offsetting all of the subsequent indices. And so you need to kind of internally keep track of that. And so magic string has this like linked list, and it has this heuristic about edits probably being close to each other. So it's a pretty easy and efficient way of editing code. And let's just make one more change before we carry on. Type equals literal node value equals self code overwrite node.start node.end. This is a Svelte Preservation Society. Okay, so that technique kind of works for some things. It's something that we use in Rollup, which is a module bundler, and it works there because you're basically just concatenating the input modules on the left-hand side and generating a single output bundle on the right-hand side. Right, that's how you take a bunch of different source files and turn them into something that can be easily run in the browser. And you see that we're not actually changing very much. Like, we're changing this export default 42 into var answer equals 42 just by overwriting that string. And we're getting rid of the export default there and turning it into a module.export. But we're just making small edits here and there. Most of the source code stays untouched. And so in that context, it works pretty well. And we thought that it would work pretty well for Svelte as well. And it kind of works. But it turns out that when you're making lots of edits in lots of different places, that technique starts to fall apart eventually. So this is an example component that we have on the website. We have some transitions here, and we have an if block. Right, if visible, that code corresponds to this code here. You will understand how that transformation happens. Thank you, Swix. We have some code here that is getting kind of plucked out and then moved into a different place up here. Here. And then we're kind of inserting all this other code in between. And that process starts to get a little bit chaotic, especially when we're doing stuff like taking some of the things that are in the script block, like this let visible equals true. We just put that inside the instance function, like Sean showed earlier. But then other stuff like this spin function, because we've been able to determine, or the compiler has been able to determine, that it's not using any local component state, it'll just take that function and it'll hoist it out of the instance so that you don't need to recreate that function every time you create a new one of these. So that gets moved up here. And if you're doing all these things, like you're moving things out and putting them in different parts of the output module, then this technique starts to get really, really hairy. And a few weeks ago, I was like, I'm over this. We're going to change it, and we're going to do the traditional thing of actually editing the abstract syntax tree and turning it back into real code. So, what I'm currently engaged in on the Svelte repo is this big PR that is going to completely change how Svelte generates code. And we're using this thing called Code Red. Couldn't come up with a better name. I wanted to have like codeine, because like pain-free AST generation, but it was taken. So now I'm going to just put a letter B in front of that, and that turns it into a tag template literal, which if you haven't used these features of JavaScript yet, insanely useful. Change that, we don't need the text anymore, so we're just going to get rid of that. Log it out to confirm that everything's working. I'm just going to comment that out real quick. Oop. Right, so we've got our abstract syntax tree again, or at least an array of statements. So we can now just get rid of acorn and magic string. They're not doing anything more for us anymore. And just like before, we can walk over the AST, but this time, instead of overwriting the code, we're going to call this dot replace, and we're going to create an expression this time, console.log, and then the same here. And now we have an abstract syntax tree that has been edited, and actually if I do the whole JSON.stringify thing, then you'll be able to see that I'm not making that up. Right, so we've got these console.log things here that have been, so this expression has taken the place of all of the alert expressions. So the final challenge is to take that abstract syntax tree and turn it back into, yes, George?
Just quickly, what's the difference between X and B?
So earlier we were talking about the difference between expressions and statements. B will create a block of statements. X creates an expression. I thought maybe you could get away with just having one thing that did everything, but it turns out not to be the case. So that is the difference. X is creating an expression. There's a really nice library called, I think it's pronounced A-string. Do you know what? Live coding is really difficult on one of the new touch bar Mac Pros, because the keys literally come off the keyboard. I should get one of them. So it's like yeah, the T key is particularly sticky. Right, and hopefully this is going to work. Right, okay, so it's now taking the modified abstract syntax tree and it's turning it into the code that is actually going to run. And this is the process that Svelte is in the middle of adopting, and the next release will be doing it this way. Okay, so here's where it's going to get a little bit mind-bendy, because I don't want the process of compiling your component source code to become slow. And if you have to fire up Acorn for each of these expressions, then it's going to add some overhead, which we don't want. And so what I want to do, and it remains to be seen whether or not this will be possible, is to write a compiler that compiles the compiler that takes these expressions and actually replaces them with what they are. And by the way, I don't know if anyone's a TypeScript user here, but TypeScript means that like, if I just start typing here, it's already ready to like auto-complete all of the different types that are possible, which I think is quite marvelous. So it would literally just take the tag template literal and turn it into the AST equivalent, so that you don't get the overhead of parsing it when you're compiling your components. So it's like compilerception, there's compilers everywhere. And that is coming to a Svelte version near you soon, hopefully.
Hey Rich, you might get to this, but what benefit does that bring you? Like being able to do that?
This is the very next slide.
Okay.
It is an excellent question. It is perhaps the most important question. So yeah, there's a reason that we're doing this. Number one is make the code base less cobwebby, because like all of the code that generates the output of a Svelte component at the moment, it's really convoluted, and every time I go in there and have to change it, like it makes me wince. And because of that, it's one of the factors that means it's kind of hard for new contributors to come in and help with building Svelte, which is definitely one of our long-term goals. It means that we can eliminate an entire class of bugs, because we don't need to worry about whether a particular expression needs to get parenthesized to maintain like the correct operator precedence and all of that stuff. There are things that, like, when you get into the details of this, you find some truly frightening edge cases, and we just don't need to worry about those anymore, which I'm very excited about. And lastly, it opens the door to various optimizations. When you're thinking about this stuff in a structured way, you can start to apply more transformations after the code has been generated. Like you can collapse consecutive if statements, and you can do all sorts of things that like you can't just trust a minifier to do, because in the context of a minifier it's unsafe, but in the context of code that we know has certain characteristics, we can apply those optimizations. And so in theory this will make Svelte component code smaller and faster over time, and that is the why. And I don't even have another slide, it turns out. So that's my talk. Thank you for listening.
Cool. So we're going to take a quick break. There's water out there and I think whatever other stuff that they have. We'll come back at 8 and then we'll have some suggestions for stuff that we can all hack on and work together. And I'll see you at 8. Thank you.
That's awesome. Well, thank you for making that possible. No, that's great.